So, the great and the terrible thing about Monitorama is that we're all kind of talking from a theme. So this meant that I didn't get much sleep last night because I had to throw out half my deck after yesterday's speeches. And today I should probably throw out the other half. It's not good being at the end of the day. But hey, I hope that I'll be able to put a different spin on it. So full disclosure, I work for a vendor, I work for Moogsoft, but this is not a pitch conversation, so I tried to keep it as generic as possible, but that will probably be informing my thinking. I just want to get that out there up front. And just like every other vendor that's presented, we're hiring, yay, hit me up with CVs. So before I got that mouthful of a title, I used to have an honest job as a sysadmin. I was responsible for, together with some other people, for running a data center with a whole bunch of servers and network devices and whatnot, and developers doing stuff to it. But because this was back at the turn of the century, the way we monitored and managed our stuff was I had a 20-inch CRT monitor. This is a big deal in 2000. And I had 6 very carefully tiled X terms across it, each one tailing a different log. And this was perfectly sufficient to be able to manage that type of environment. Doesn't really work that way today. And yet, we're still trying to manage our very, very different world in the same way that we did when we had the type of environment that I was dealing with back then. Why is my timer not advancing? I hate computers. So the old world that I was dealing with was a world of physical devices, the famous hardware that you can kick, right? You had a relatively small number of them compared to what we deal with today. And you didn't get surprised because new ones would show up. Getting new hardware was a whole process. You had to raise a purchase order, and the thing would be shipped, and it would show up at the loading dock, and you'd rack it and cable it and install it. You had a good long time to plan how you're going to manage these things in your environment. Developers also developed at a much more leisurely pace. Plenty of organizations were doing deployments every 6 months. And so that left plenty of time for the change advisory boards to meet and debate and for you to have your plans and mitigation in place, all of that. The environment I was working in was slightly different. They were into extreme programming, and year 2000, this was early days. This is what then became DevOps and Agile and all of this, so they were already starting to talk about that sort of thing. And yeah, we sysadmins didn't like them very much for that. There's a cause of friction there. But this type of environment generated manageable alert volumes. Again, 6x terms, perfectly sufficient to manage a couple of hundred servers. The problem, in fact, was getting enough information from the systems and devices to understand what was going on. A lot of the time, I didn't really have full visibility. But once I did get the data onto my screen, it was pretty easy to get a picture of what was going on, what was happening, what was useful for me to know at that point in time. Literally none of that holds true anymore. We have enormous numbers of things to manage for various definitions of things, and they're changing all the time. They're being changed by people, the same organizations that were doing the 6-monthly release cycle. Now people are releasing multiple times per day into prod. And this would have caused heart attacks 10 years ago, but now it's just normal, it's standard. Why would you not do that? And the things are changing themselves. There's automation built into many platforms, and of course, there are all sorts of additional automation frameworks that people are using on top of that, so that the system will reconfigure itself in response to user demand or outside events. It'll flex and flux and all of this. And so all of this activity is generating incredible volumes of information, of data that we need to look at and figure out what to do with. So it's no longer a question of laboriously polling systems to try and get that one piece of information. It's just a constant torrent of events and anomalies and metrics coming at you all the time, and it's up to you to figure out what's important to you to do your job. And so we get a lot of specialization, lots of different teams around using different tools to look at different aspects of the infrastructure. I'm a Linux admin and I use Nagios. I'm an application owner and therefore I'm using AppDynamics, and never the twain shall meet. It starts to be difficult to get that comprehensive picture of what's going on in the environment, because you can't fit it all on one screen despite the best efforts of dashboard vendors. And so we spend a huge amount of time managing our IT. In fact, a lot more time and effort on managing it than we spend on using it for the purpose it's supposed to be there for. Very few of us are doing IT for the purpose of IT. Most of us are doing IT to support some sort of business use case. There are users out there who want to use our thing, and we have to keep it up and running and performing so they can do their jobs. But that job is made more complex by the rate of change. So I love this quote. It's from outside the IT industry, yes, but I think it describes our world down to a T. So earlier this year at Davos, Justin Trudeau, Prime Minister of Canada, said, pace of change has never been this fast before, and it will never be this slow again. The graph continues to accelerate, to go up and to the right. There will be more and more change in our future if we think, no, now we've done all the change, now we can slow down and digest it. Not so much. That's not how it's going to play out. And all of this change leads to enormous amounts of complexity, which is why, according to a little idea, every 9 costs 10 times more than the previous one. And anyone who's tried to make a system just a little bit more reliable has run into this wall of diminishing returns for every little thing you can do. So it's in the Google presentation just now. We did a whole bunch of work, and that got us 25 milliseconds. That's great. Well, at the types of scales that we're talking about, yes, but it is a lot of work. And part of the reason is that life is no longer as easy as it was when I was running a data center. I could rely on all of the things that I was managing being plugged into a cable, and that cable being, at the time, 100 megabit Ethernet. These days you can get gigabits, optical, whatever, and you have good connectivity. And everything that was happening outside the secure door to the room, not really interesting to me. What was happening out at the edge was secondary to my concerns. That's no longer the case. We have massively distributed infrastructures, and the intelligence is being pushed out further and further. Telco is probably the world that's going through the biggest transformation in this sense. They used to be able to safely ignore CPE, customer premise equipment, and these days even your DSL modem is a full-fledged Linux computer that needs some sort of management, lest script kiddie own it and start using it for nefarious purposes. But the edge is really far away. You can't rely on having that connectivity. You probably have limited bandwidth if you're running some sensors out in the field somewhere on oil rigs or whatever. Limited bandwidth, unpredictable, unreliable. And in an environment like that, there's always something going wrong. You cannot assume that because you got some sort of message that's interesting or important, what you have to do is figure out, did I just lose one sensor sitting on a fence pole? Or did I lose the 2G network bridge that was letting me talk to a whole region? Did I lose one production line, or did I lose an entire factory? Did I just lose connectivity, or is it actually telling me something? And so we have to architect our environments, our infrastructures to support that. Single faults are no longer interesting because we long ago dealt with the single fault issues. If you're being taken out by a single point of failure, you probably made a mistake somewhere. Hardware is cheap, it's reliable, it's, relatively speaking, easy to make redundant. So it's not about the single thing happening, it's about the overall environment being able to tolerate losing a percentage of its capacity at any given point in time. So we just have to internalize that in our thinking. Because as usual, there's a difference between the theory and the practice. The theory is that we have this perfect world in which, well, for a start, there are no users in this picture messing around and finger poking. It's all nice and clean and safe and predictable and looks exactly like the diagrams that we mapped out on the whiteboard. The real world looks more like this after all the compromises and all the things that we had to do after that thing that happened that one time. It's a lot messier, and we have to be able to roll with that and deal with it and work out on the fly what we need to be doing in that situation so that we can keep the thing up and running that is supporting the end users. We need to change the way we do monitoring because the systems that we're monitoring have changed. It's no longer the world that I came up in as a sysadmin. It's a very different world. And the tooling and the processes and, yes, the people that manage that need to catch up as well. By the way, you should notice I'm doing this on hard level because for some reason I can't see my speaker notes, but it's all going well so far. So the world we're living in is a world in which we don't have full visibility. Because when I was a sysadmin, I was able to go up to a server, and I knew that this server supported this application, and if I needed to know something about it, I could go and call Bob, who was the owner, or Alice, or whatever, who was the owner of that thing. These days, if you're running infrastructure, as we just said in the previous talk, that's very much decoupled from what is running on top of that infrastructure. From your point of view, sitting at the bottom of the stack and looking up, it's really hard to tell what's going on. They're all different things that are not always visible to you, what they do, how important they are, to whom, and why. And so what you end up doing is running very, very fast in order to be able to keep the lights on and not be caught by all the various alligators, etc., that are always snapping at your heels in the world of ops. So it's not an easy life carrying the pager. But the problem is, because IT is everywhere, the consequences of failure are very, very, very visible. Not just to you personally because you go backwards into the alligators, but because you hit the front page news. So let's talk about that for a moment. Whereas this isn't just the classic vendor slide, oh, these people didn't buy our software and bad things happened to them. It's a little bit more interesting than that. So let's take the first one, Amadeus. They run booking software. If you flew here from anywhere in Europe, you were unwittingly using their systems. They had a relatively minor outage in their data center. I think they didn't even breach SLA. But the consequence was that across the world for several hours, basically anything involving Lufthansa, Star Alliance, United came to a complete screeching halt. Munich airport had a 4-hour ground halt. Nobody was able to board or deplane at all in Munich. So big difference between the little 15-minute outage, that from the point of view of the sysadmin, oh yeah, we got to stop and running, that's fine, let's get coffee, and a whole lot of frantic screaming and running around. Bank of America, same kind of thing. Relatively minor outage. Again, fairly sure they didn't breach SLA, but across the whole of the Midwest for multiple days, people were unable to use the ATM to get cash. I work in a distributed team. I do have now one person who's in the same time zone as me, but I haven't had a boss in the same time zone as me for a decade, so I live my life in Slack. Slack goes down, it hits me hard. I have to go back to email like an animal. Yes. So yeah, that's a big issue, but also on a personal note, New Year's Eve, Hogmanay, WhatsApp went down and people were unable to send their New Year's greetings to each other. That's a very, very visible consequence of a minor IT failure. Quick, an alert, a page. What do we do about it? Let's have a good blamestorming session. First culprit, well, it's always the network. Once we've laboriously proved, no, it's not the network. Well, it's a database in that case, for sure. And then we can start the proper debugging. But seriously, what normally happens when the page comes in is we start the war room, we get everyone around the Polycom, and everyone starts pointing fingers and trying to figure out in whose responsibility this thing even falls and what do we do about it. And that's how we wind up in those bad situations. Vendor, sorry, bad habits. I have to use some analyst slides somewhere. But these were actually from a survey that the analysts ran, in this case Forrester, of CIOs across the industry. And I think what it said was interesting. So a big one is, for many, many people, end users are still the first line of warning. The first sign of something going wrong is angry users on the phone. That's not exactly ideal. Also, because you have this very end-user-focused way of looking at things, you often start from the point of view of the application. The application is down. Application may have nothing to do with it, but you're dealing with that as your first sign of something going wrong, where the root cause is actually way down the stack. A whole lot of tickets get escalated because they land on someone's desk and they go, I don't know what to do with it. And so they escalate it not because of a lack of technical knowledge, but because of a lack of organizational visibility into what's going on. And for the same reason, lots of tickets get reassigned across silos. In fact, I was working with a company earlier this year, and a significant percentage of their tickets get reassigned more than 5 times. That's a whole lot of wasted time when nobody's actually working on solving the issue. It's just friction. And so for lots of people, the notification, there are lots of tools to do notification, but the big one, panicked screaming. This is an actual user survey that we ran at SREcon earlier this year, as people came by the booth and we asked them to fill out a survey in which, among other things, we asked them, how do you find out about problems? We hear the screams. That's not ideal. So how do we fix this situation? Easy. Monitor all the things. Obviously, right? Now, someone already told the story yesterday about Abraham Wald and the bombers over Germany, so just very, very quickly, in case you missed it. This was big data, 1940 style. We're going to go and bomb Germany, and the Germans are not in favor of this project, and they keep shooting holes in our airplanes. Where do we put some armor so that the airplanes don't get shot down? And the initial simplistic reaction was, well, let's look at where the bullet holes are and put armor there. And this guy, Abraham Wald, came up with the brilliant insight that no, actually, what you want to do is put armor all the places where there are no holes, because those are the places where airplanes got shot full of holes and did not make it back to the airfield. So that's how you do that. So this is kind of counterintuitive, though, this survivor bias. We tend to look at the things that we know cause problems, and we don't think about the things that don't. More on that later. So the way we've been doing monitoring until now is periodic polling. Let's regularly go and check, is it okay, is it okay, how much of this is it using? But this produces enormous amounts of data, and so we filter it pretty aggressively. We try to figure out, what am I going to want to know at some point in the future when something is on fire and my boss's boss is breathing down my neck asking me to solve it right now? It also tends to be a late addition to the process. It's not designed in. This is changing, but by and large, in large enterprise organizations, sort of people I talk to, it's still something that's added on afterwards. And it's very instant-driven, it's interrupts-driven. Something's happening, let's do something about it. A bunch of hidden assumptions in there. The information is expensive and therefore valuable. That you have to go to a certain amount of effort to get information, and therefore you should do something with every bit of information that you get. Not necessarily the case. Secondly, that faults are easy to detect. We have all of this data, therefore we should be able to tell what's going on. The problem with that is a notion called the Byzantine fault. So this goes back to the days of horseback messengers. So you have a bunch of generals all besieging a city, and they need to attack all at the same time. So if just a couple attack, Leroy Jenkins all the way at the city gates, then they're going to get decimated and nobody's going to take the city. It's better in that case if they all just go home. But they need to coordinate and synchronize their actions by horseback messenger, with the additional variable that some of them may be traitors that are actively trying to sabotage the others, and the horseback messengers may be also getting lost, eaten, shot full of arrows, etc. along the way. Surprisingly similar to monitoring, really. And the final assumption, the biggie, that all failure conditions are ultimately knowable, that our systems are predictable. There's all sorts of mathematics behind that one that we can get into offline. And so if we just throw everything up on a dashboard, and as long as things are green, everything's fine, no. That's how we get really angry users when we tell them, well, dashboard's green, everything's fine. The internal health of the system is actually irrelevant from the point of view of an end user. What they care about is what they're trying to do, the request they're making. Can I do my thing? Can I do my job? Can I hit deadline? Plus the other thing, as we're just talking about, we assume that we know what's going to go wrong because we're looking backwards, we're looking in the past. Every dashboard is an artifact of a past failure. Something went wrong. Let us create a dashboard so we can know if this ever happens again. You end up with a very, very big dashboard. And this is why nowadays we've switched to talking about observability. So observability is more about continuous stream of real-time data, huge amounts of data, very high count of data, and it is built in to both infrastructure and applications. Modern infrastructure is generally already instrumented out of the box. It has APIs that you can call. You don't need to install an agent on your Docker images, on your containers, on your serverless platforms. It doesn't work like that. And so it's much more about, oh yes, and also our developing brethren have very much got this message as well and tend to build it right into their thing. You don't have to try to inject stuff afterwards. They generally instrument their code, at least to some level. You have to have the conversation, but it's a conversation that is finally happening. And the final thing is it's insight-driven. It's not something is happening, it's something important is happening that you care about. Big distinction there. So the realizations that drove this are that information is actually cheap in this world. In fact, information is so cheap, it is valueless on its own. It's only useful if it can be queried, if you can do something with it, if you can gain some insight, some understanding you would not otherwise have. The user experience in this world is not an afterthought, it's a key part of what you're looking at, a key diagnostic information source. Just don't treat the users as your first line of warning. Try to have something up front so you're not bothering the users every time. And so we're moving from this old world that's instant-driven, that's all about resource consumption, to a new world in which we can get new resource very easily. And so what we're all about is the insights and making them actionable, being able to do something about them at the useful time when they occur. So how do we get to that point? How do we find actionable insights? We just take all of the data and we put it in one big bucket, so big that we might call it a data lake. As we said, though, data is not actually useful in itself. Just because you have a lot of it, it's not very useful. But we can go and sift the data lake and look for patterns, try to see if we can spot, last time X, Y, and Z happened, the consequence was this. So if this happens again, we should know about it, right? Not necessarily. That's like driving down the road, looking only in your rearview mirror. The objects that you find may be less relevant than they initially appear. Because of the rate of change of our infrastructure, as I was saying at the beginning, there's less and less of what happens that is predicted by past performance. Many things are happening for the very first time, and that proportion is only rising. Already today, many of the operators that I speak to, less than 30% of their incidents are actually recurring. 70% are occurring for the very first time, because the environment has changed since the last time they looked at it. And so the validity of your insights from the past is going to be limited. Not valueless, it's one tool, but don't rely on it as the only one. And the reason for that is not to get into politics. Everyone has at least one good day. And so Don Rumsfeld talks about the known knowns, the things that we know, and the things that we know that we don't know. These are the easy ones because we can go looking for them. What generally bites you is the things that you don't even know to go looking for, the unknown unknowns. And in this world, this very dynamic world, this self-configuring, self-modifying world that we're moving towards, there are more and more of those out there. I think I've got time for a very quick story. So, major Swiss bank, I won't tell you who, but we're working with them, and classic thing, everything's going into silos. So one monitoring tool feeds to one team that opens their own ticket and starts doing their investigation. In this case, everything started from networking. There was a networking device, and it had a flapping port. Relatively minor issue. We'll get to it. There's a ticket open, but it's low priority. Except on this port, one of the things that was talking on that port was NTPD. It was sending network time protocol signals. And NTPD would occasionally have a hiccup when the port flapped. And the Unix admins were aware of this. They had their own monitoring tool that was telling them about NTPD. It's time. And, we'll get around to it. We'll fix it, but not right now. It's not a P1. Except that one of the things that NTPD was supporting was WebSphere MQ. And every time yes, someone has used WebSphere MQ before. So every time NTPD hiccuped, WebSphere MQ would drop its entire queue on the floor and reload it from disk. And this caused an entire trading floor in Southeast Asia to go dark for several hours, causing many traders to become very unhappy and the bank to have a multi-million-dollar loss. Because the three teams were each individually aware of their thing, but they weren't talking to each other and they didn't have that visibility. Because everything's just going into a silo, they're going to different teams who don't talk to each other and probably don't like each other very much. And so things get lost. What we want is a very different world, one where you may have the very same data sources that you're talking to now, but they feed into a common bus. I put Kafka on here because most of the people I'm talking to right now are using Kafka, but there are various other buses that you can use. Everything reads and writes from that bus, including the various processing tools that you're using to understand the data on that bus, and everyone therefore can have a common understanding of what's going on. But wait, how do you get that common understanding? And here is where the AI finally comes in. The AI is the only way to make sense of these types of volumes and frequency of data. So let's unpack that, because many people just had their little cynicism alarm go off in the back of the head. A vendor said AI. So let's unpack exactly what I mean by that. So first of all, we're not talking about robots and going to wheel out Pepper on stage and we can ask her questions. These are tools from data science. So AI is the superset. We generally are talking more about machine learning. And there's also a notion of deep learning, which is a further subset of machine learning. Machine learning is the science of getting computers to do something without you having to actively tell them. And what that means to us in IT ops is that the machines will tell us what we need to know without us having to laboriously decide which sensors we are going to need, which data we will want, how to filter that, whether we consider this a severity 1 or a severity 4, without having to tell them up front. The specific ways that we use these techniques in IT operations are basically in 3 places along that process. The first point where you can use AI is right at the point of ingestion. Do I want this event, or is it pure noise that is just going to be a distraction? Is the event even significant to me as someone responsible for operations, as someone who will get paged on that event? You want to avoid false alarms, but you also want to avoid false negatives, for both false positives, which wake someone up for no good reason, and false negatives, which means someone didn't get woken up when they should have, when that would have averted a bigger problem. The next step is, okay, so we have some significant events. How do we identify when those events are related? Because remember, single event failures are rare or should be. What we're interested in is how those events all relate to each other to describe a bigger problem that we need to be looking at, especially being able to do that across different domains and being able to understand the total problem, avoiding duplicate efforts, tickets being reassigned, all of that stuff. And the final piece is, okay, so now we've got different domains involved. We've got network and database and application and maybe the business owners as well. We need to help these people work together. So we need to identify the owners, plural, of the thing that we're looking at. We need to help them look at what's going to be the root cause, because that's always a thing, what caused this problem. We need to give them knowledge. This same thing happened last week. Would you like to know how your colleague solved it last time? All of these types of things. So AI doesn't just apply to the technical monitoring, it also applies to the human factors at the other end of the process. So we need to teach the machine to be able to do this. Part of this is working on the data. Inputs matter, so choose the right feature vectors that describe your problem, the sorts of things that you care about. You also need to understand a little bit about the different ways in which you can use AI, so regression problems that are described by something will fall within a range versus classification problems, something will fall into one of several buckets, and how you define your buckets, how you use these things, is going to make a difference, but it's very much worth doing. Last analyst slide, I promise. This one's from Gartner, just to split the difference. But Gartner are actually the ones who've been doing a lot of work in defining where AI fits into IT ops, and they came up with this framework called AI ops, where AI ops is not displacing any of the existing categories. It's a new category at the intersection of monitoring, of service desk, or the process piece, and automation. So instead of wiring your monitoring directly into your ticketing and getting a bunch of spurious tickets, or directly into your automation, and maybe getting the automation going haywire and a bit of Sorcerer's Apprentice effect, you have the intelligence in the middle that's doing the work for you. So starting to bring it home, in practice, what does that mean for you as you start leaving Monitorama and going back to your day jobs? First thing, this is IT ops. Speed matters. It has to be real time. The best algorithm in the world that can tell you what happened last week won't help you right now with a thing that's going wrong in front of your eyes. You won't always you won't always know what you need to know in the future. So better to err on the side of variety, give the machine everything and stir it vigorously to try and get some response. But AI is a tool that's not magic. Don't expect it to be just a black box that you plug in and it does stuff. You do have to put some thought into it. And it has to fit into a process, and your process will change. If your process assumes linear, waterfall approach to problem management, then it's going to have to change to a much more agile approach where you interact with other people. It's not my problem, and then I hand it off to another group. It's the two of us are working together on the problem that the robot brought to us. Why are we not doing this already, you might ask? Especially the AI bits. A lot of these techniques are not new. They date back 50 years in some cases. Classic Greek triad, Thucydides, 4 centuries BCE. Fear, people are afraid the AI is going to take my job. Don't worry about that. Every company, as I've seen, that's adopted these techniques, they found plenty of other things for the admins to do. All of that long tail, the backlog, the stuff that you've always wanted to do and there wasn't enough time, you can start getting to that. And that will make the users much happier because you'll be doing a lot more work for them. That also speaks to the honor aspect. You want to be a hero. You want to be a hero to the users. It's actually better to be the one who kept the lights on rather than the one who rushed in and fixed them after they've gone off. And self-interest, once again. We want to be very much involved. We want to own it. A lot of us still have a little server hugger gene at the back of our brains. But you should start right now. These tools are incredible force multipliers. When you start adopting these techniques, you can get a lot more done, surprisingly more, with the same level of effort that you're currently putting into running as fast as you can to stay on a line on the floor. Thank you very much for your time.